All right, guys. So good morning.
Yeah, right. No, the direction is correct, but I just want to make sure that you found like the accurate.
Yeah, I see.
Okay, yeah.
Because just example of like that.
Yeah.
Actually for sure.
Go ahead.
All right. So we going to continue on the objective four. All right. So what are we up to right now? Um, I think we have learned about the mean, the standard deviations, the variance, property, and then
Well, where was the point that
yeah. So
where was the what you used the keyword. Yeah. Right, and the origin is on what side of the line?
we going to computing this and So for the John probability, making sure that we have like X and Y correctly. Um, so this is stat 113, and then we continue on the objective four. Objective four.
That means that if you take a test, now you know that because this is a linear methodology,
Continue.
it's either going to be this whole half length or this whole half.
All right.
The way
So
to see which of the two it is.
all right. So we have to go with the John probability, right?
And
Like
see
with two variables.
if it satisfies. If it does, then that means it's.
All right, so let me see. Let me just pick one example quickly for that. What we have over here is, the chart.
So that means that the origin, which means that points that are on the same half length.
All right, so we just simply add up so the question just simply asks us to add up the probability. So it's not a big deal for this question. It's just so the P of X equal to -4, just simply add up like 0.04 plus 0.12 plus 0.00, you got 0.016. And then we do the same thing for that, just add up the probability of X equal to -3. So just add up 0.12 plus 0.36. Which is actually going to give us the answer, which is 0.48. And then the same thing for, because keep adding up here, you're going to get this one is 0.14, and this one is 0.22, this one is 0.48,
That's kind of like why you want to use the password.
and this one is like
It's not about
0.16. So we add up the total probability, must add up to ones for X. And then the same thing when you add up a total probability for Y, you should end up with the one as well. Okay, so uh in other words, when you add up like this one, so this one is like the probability of Y equal to -4. So we just simply add up the 0.04 plus 0.12 plus 0.00 plus 0.2. It's actually going to give that equal to 0.36 as well. Yeah. And then we do the same thing for the probability when Y equal to 1, just add up those two. We get this one is 0.49.
I'll see you later.
Then we add up this, you're going to get 0.15. So no matter how we're going to add them up, so the total have to be exactly 100%. So yeah, so that's very straightforward. How we get to simply add up the probability for X, for Y, for each row and columns respectively. And then when we add up the total number of rows, we get 100%. When you add up the total number of columns, you also get 100%. So that literally what we have. Yeah, we just simply add each row. So let's say this represents the probability for X equal to -4, Y equal to -4. So we got this one equal to 4%. the probability of x equal to -4, y equal to 1, you got 12%. For x equal to -4, y equal to 4, so we got this one is almost 0%. So when you add up these three, and then we simply get the probability of x equal to -4. So the joint probability would be the probability for each box, right? When you add up like 4 rows of box and 3 rows of column, you should get 100% as well. In other words, you can also find the total column for each row and each column. So you should, basically get the same answer, which is 100%. When you either add up the row, total number of row and total number of column, they must add up to 100%, which is 1. Okay, so any other questions that you may have? Yeah, so we do the same thing for this and this, you end up with 100%. Okay.
And then number. So that when then you multiply everything, it comes out. You're kind of reverse engineering.
Yeah, so this one you just have to assume like this one you have to assume like this is 0.15 or something like that, and then you can find the other one, and then you have to assume one number. It doesn't matter which one. You can assume this one's like 0.05, and this one had to be 0.05.
I know.
And so if this one is 0.05, when you add them up, you got 0.11. So this one has to be 0.19. You subtract from 0.3. And the same thing. So the total number of the column must be added to 0.7. So we can take 0.7 minus 0.05 minus 0.14. You got that equal to like 0.51, something like that. So you can assume. Oh,
Different numbers that.
oh, they're independent. I'm so sorry. So let me try another one quickly. I do apologize. So, I haven't read the questions carefully. Okay.
And there's -5 and -4, right? These are our or like up to like flipped as well. So this is kind of like our.
So we have to assume if
Create our pool of
A and B are
for these guys.
independent, right? So for example, we have question number this. So the question said if X and Y are independent. So
The sign, we can assume that this is going to be a plus.
So what it means by that is that the probability of X and Y
But that is something that we can.
is gonna be equal to the probability of X times the probability of Y. Okay.
This number.
All right. So for example, if they are independents, like we said earlier, so the keyword for that was like independence.
Outer.
So we have to assume that when you multiply the probability, they must be the same.
And then last.
So in other words, we can simply multiply like 0.5, so P of X equal to -2 and Y equal to -3. You can simply multiply like P of X equal to 2, -2 times the P of Y equal to -3. We'll multiply them together. Just simply take the row times the column. So that'd be 0.2 times 0.5. You get 0.1.
We're either gonna have 12 and 2.
So yeah, so you got this one is 0.1. And then after that, we can look, like we can also use the property. We can also figure it out P of X equal to 2, the P of X equal to 3, P of Y equal to -3. We can simply, we can also multiply like 0.5 and 0.8, which is 0.4. Or we can also do like, we can also do like 0.5 minus 0.1, which is did earlier, because the total probably have to add up to 0.5. So you can take 0.5 minus 0.1, you get 0.4. So It's really up to us whether you want to do it this way. You can subtract them, or you can simply multiply the second row with the first column. The same thing, you're gonna take 0.2 times 0.3, you get 0.06. And then we subtract from 0.3, you get 0.24. Or we can also multiply 0.8 and 0.3 together, so we get 0.24. So,
When some.
all right, so that's what it is. Are we good? It's very straightforward. And if the question says like dependence, for example, so we can, if the question says
That like how oil works in general
dependence,
is what kind of makes it necessary that this is true.
so then there's no
So-
way we
I
cannot
already said
assume
that K, sorry, we want,
Assume P of
KQ
X and Y, right?
plus
Equal to,
M
so P of X times P of Y. So in other words, we don't have that property, right? So in this case that we need to assume like one of them,
what we
right?
want to do is
Assume just give one of those probability,
we have to kind of go by trial and error.
one of those.
So one thing that we know is that
For example, you have that
we
you
are
have these
going to
questions
deal
where
with,
you know the question says, well, they're dependent. There's nothing you can do. We should not multiply them, right?
let's start with the fact that, well, one of the two couples is gonna have to be negative.
Okay.
Right? Why? Because
So they are dependent in this
or-
case.
so let's take a step back. So minus 52.
Okay.
What can you see any two numbers? Or actually like technically any four numbers
So we have to assume one of those. Just make sure we're not multiplying, right? Do not multiply.
that when they are multiplied together and then some.
So all we have to do is just assume this one, like let's say this is 0.05,
So we have
something like that. As long as it's not equal to 0.02, that's perfectly all right. And this one has to be 0.05. And then this one is 0.05 as well. When you add them up, have to be equal to 0.2. So we just take 0.2 minus 0.1 and minus 0.05. You got 0.05. And then the same thing, you can take 0.4 minus 0.05, get 0.35. Right.
40.
So you can take on any value. It doesn't really matter that much. So this one is 0.05. But this one had to be 0.05.
Go with two.
So this one 0.05, you have to do like 0.05 as well, and this one is 0.35. Okay.
And these guys. Then
Yeah.
necessarily we're going to
Yeah, we cannot. We just cannot multiply them. We just have to choose any of these values, but make sure you're not going to multiply the 0.2 and 0.1. The total of the row times the total of column. We can only do that if they are independent. Okay, just pick any values. I think that's perfectly all right. And it should be giving you the correct answer for that quickly. Okay. As long as this is not like 0.2 times 0.1, but so they're not independent. Okay. They're not independent. But anyway, so let's move up to the next question. For the dependent, it's just like we can assume any value as long as less than 0.1. You're perfectly happy with. You can take like 0.09, and this one is 0.01, and this one is 0.01, and this one is 0.39, something like that. It's perfectly fine. It's perfectly all right.
Plus, what is the K that we found?
All right, so let me move up to.
So that's gonna be plus 6. And then on the other side, we're gonna have Q.
Let me just move up to the app questions where we need to understand what it is.
Sorry, this is minus. And then we're gonna have
So
2W times M, which is minus 4. Now, what would have been something that we could have done done at the start to make finding these numbers easier. 20, 52, and 20.
So the joint probability that we had was given, and then so the question I'm gonna ask is to do like this, okay?
Yes. To the third. So
All right, let's see how we're gonna compute this. Oh,
rewritten this.
so given that x equals to 3, and they want to compute the p of y, right? So we want to find the probability of y equals to 3,
And then
given
we're
that
gonna make
x
sense
equals to
between
3.
here, but with much smaller numbers, which means much easier. Because that means that our only options for this would have been 5 and
So
5 and -5 and -1.
So we can take the joint between like p of y equal to 3 and p of x equal to 3 over the p of x equal to 3, right?
Yeah. I don't know which one you're.
So I just use the conditional probability perspective
Like, do you wanna?
probability. And then what we have to do, just like, well, we have like p of a given b equal to p of a and b, right?
You mean?
Over,
Well, in that case, we would have had
p
to
of
make
b. Okay?
the whatever couple respected this sign as well. I don't know if this has a solution. It might be possible that there isn't a solution.
So the a was like y equal to 3 in this case.
But you would have just it's the same logic, just with just you have to take those signs into account as well.
And then the b
um,
was x equal to 3, so you can think of that.
personally, I think it's
All right, so you can look at that. So it's given by x equal to 3, which is 0.12. And then the numerator is going to be y equal to 3. So we have to add up the total probability for x equal to 3 as well. So for x equal to 3, you can just simply add up like p of x equal to 3 equal to 0.05 plus
let's start with
0.11 plus 0.1 plus 0.2.
this two. We want to have something
So when you add them up,
like this, right? So let's
it's going to give us 0.38.
want to look at what your so what are the
Okay.
possible factors of phi?
So that's the total.
What is a prime? So that means that you don't really have that many options.
Okay. And then, so that's the probability equal to 0.38.
Yeah, 30, it's just a way to say like, you know, when you have an area, like you have a square, right?
And then on top of that, we're going to pick the joint y equal to 3, x equal to 3, so it's 0.12 this one, right? So we simply take 0.12 over 0.38. You should be able to get to the final answers correctly.
So in this case, okay, that's also good for that.
You get like 0.315, 0.316. It's asked us to round up to 2 decimal places, it's 0.32. Okay, it's 32%.
Plus this, like this, to be equal to.
And then we can also do for part B where I want to put compute probability of y less than equal to -2, given that x is positive. Okay. So this one is kind of like really trick questions. So given by x positive, so we're gonna get like 2 x positive is like this part, right? The whole thing. So we're gonna take the probability of y was probability of y less than -2, and x greater than 0. Okay.
But it's not gonna be
Over the probability of x is greater than 0. Oh, we don't count 0 actually, so I'm so sorry. I think the block is wrong. We don't count 0, we just calculate. So 2 and 3. For x equal to 2, x equal to 3. So we're going to divide it by, like, so the bottom was like x equal to x greater than 0. On top of that, going to take p of y was less than or equal to 2, negative 2, and x is greater than 0. Well, I mean, don't think of that really complicated. So when x greater than 0, just like take 2, right? So this is going to be on your denominators, right? So x equal to 2, x equal to 3, which going to give us the value that, like x greater than 0, right? So just add up the probability of x equal to 2 plus the probability of x equal to 3. So we add them up. So with x equal to 3, we add up these 3. So you got like, this is 0.16. This 0.16. This 0.26.
We're looking at pairs.
So we add up these 2's. So that would be
So put everything.
0.26 plus 0.38. So that is going to give us 0.64, right?
One.
So on top of that, we have the probability of y is less than or equal to -2, given that x greater than 0. So we're going to take less than or equal to -2. So we have to count -2, -3, and -4. Okay. But we have to count like y equal to -2 as well. So we have to count this 3, 1, 2, and 3, right? 3 of this. So on top of that, so we're going to take the joint, so this is the probability, right? Okay, so the joint for that, it should be this part. We don't take the negative value of x, we don't take x equal to 0, right? So on top of that, we're going to compute this one will be like 0.00 plus 0.10 plus 0.09 plus 0.05 plus 0.11 plus 0.1. So it should be able to give us the final answers. Just add up those 6 boxes, and then we divide it by a total of 8 boxes. And then that's going to give us the final answers, which is 0.45. So we should have like a fraction which is 0.45 over 0.64.
The other would. The other thing.
So, and then we just simply divide it 0.45
So what the other way that
over 0.64. You got this one 0.703.
a pair of numbers.
0.
such that
Okay.
P times Q.
All right, let's check the answers. That should give us 0.32 and then 0.7.
plus
And that should be correct. Is customer not just, oh yeah, it's we start with a decimal point. Well, you might,
So let's see what
Yeah.
number. And again, let's look
we might start with like 0.32. It's definitely going to be the same thing.
the final answer. Is going
Any
to be
question?
4 times. So let's see. That's going to give us EU times so A times C 5 times 6.
All right, so if no question, let's move up to the next example and let me know if you have any question or concern.
There and 3 5 10.
All right. Are we good? So you just need to know like, so let's say P of y equal to 3 given by x equal to 3. We just simply take the joint between y equal to 3, x equal to 3, and then we divide it by 138. The second part actually more complicated because it gives us less than equal to. We need to identify those value of y's and those value of x that satisfy both conditions. And then we just simply add them up and we take the ratio. So that's the final answers. All right. Any question? Any concern? Okay, so since we don't have much time, so let's move up to the next question quickly.
Um, um, what you want to do now. This does not give you the correct answer, but this does give you all the ingredients you need for that. What do those
We did
ingredients?
that before. We did that before, and then we still have like 15 more topics. I don't think I can finish all of this today. So I think, next class I have to spend times working all of this before the exam review next Friday.
-3 don't.
I'm sorry, next Tuesday.
And
Okay.
then
And then,
what you
all right.
What you do from here is partial factoring, which is another thing that we will do today. Partial factoring means that I'm going to look
For the binomial problem, so we simply know there's this by mean two, right? So the probability, but I'm not gonna actually like to do math for this. We have a calculators along the way, so I would suggest you guys to compute the mean equal to so this one we call the mean. Which is denoted by that letter, and that equals to n times p. Okay.
W and 6. What is the greatest common factor between these?
So I might change the little marker, just making sure we have this kind of information. So the questions, the n was n is followed by the sample informations, and like numbered people and have to be the whole numbers, like 40, right? Whole number.
Minus out here.
And then the p have to be like in terms of percentage, like p. Yeah, this question going to be on the exam, so I really want to make sure that people take it seriously. The previous question will also be on the test, but this one is very easy to get the points. The question says 52% is like 52% is we convert to 0.52. Okay. So we just plug that in. So the average the question says estimated expected values. So we just take, like 0.40 times 0.52. So that's going to give us the answers quickly. So
these are the two.
we got 20.8.
Two groups are correct. But if you've done your process down to a T, you'll always find your answer. Okay. There's no scenario. Well, there is a scenario, but the scenario that
and then we can also compute the standard deviation. The question we also ask is compute the standard deviation, which is for that. So the standard deviation denoted by SD is, and then we also have a syntax for that we call sigma. And then this can be computed by taking the square root of n times p times q.
I mean, what you can do, and well, first of all, so yeah, the quadratic formula does work. So what you can do if you know the quadratic formula, kind of cheat, which is really not cheating, is say on the exam, you want to double check that your answer is correct.
So the by mean two, right? So the by mean two, and then we actually have two of them. The first one we call like success rate. The p we call success rate. And then the Q we call the failure rate. I think I use different uh success rate.
That's not necessarily good, but that's.
And then the Q is like the failure rate. So the Q can be computed like 1 minus P. So the likelihood I can pass the class was 80%. And then the likelihood that you fail is 20%. The symbols we have for each case scenario, making sure that each uh, case is identically independent, so must be the same cases. So we just have to repeat the number of cases. So we just have to plug that in. We just take the square roots of n is 40 times the p is 0.52 times the q. The q can be computed by 1 minus p. So you can take like 1 minus 0.52, you get 0.48. So everything must be done on a calculator. So as precise is very straightforward. Multiply that on a calculator. So you should be able to get to the final answers quickly. So you take the square root of 40 times 0.52 times 0.48. So you get like 3.1959. It's just 3.16. It's just round up to 3 decimal place. Okay, so as simple as that, we just plug that in. So the answer is 20.8. And then the spread is 3.16, right? So we have 40 of them. You should expect to have around like 20 people, 21 people, um, the other customers order their food to go, right? And the spread would be 3.16. Any questions? Any concern? Is it very straightforward? Just plug that into the form, you can get to the final answer quickly. So I don't see any reason that you have trouble with this, unless you want to ask me that question. Are we good? All right, so let's do another questions and see. All right, so now we completely skip the discrete model. So now we got to go to the continuous model. Then we just specify a little bit about the con the continuities. I mean the continuous distributions. We use calculus to compute it, most of the function, but you're not responsible for like doing this. The question will be giving us a certain area, but the probability going to be the total area under the curve. So, and then the total probability, which is called the total area, must add up to 100%. If that doesn't satisfy this property, then it's not the probability distributions must be 1. And and we cannot get negative area. Um, for this question, the question gives the region A, B, C, D. And then it's got to give us like let's give us the area of one point to another. So if we want to find the area between 0 to 6, so we need to compute this area from 0 to 6, which is a rectangle. I'm sorry, the triangle of A and B, right? So it's just out of the total triangles from 0 to 6. It's just the area of A plus the area of B, which is 0.15 plus 0.45 equal to 0.6. Yeah, we just do that. It's not a big deal. So that's a probability equal to 60% between 3 and 8. So we add up the area from 3 to 8. We just add up the area of B plus C, which is 0.45 plus 0.3 is 0.75. It's not a problem as well. How we go? Yeah, this question usually not going to be on the test. Like I said, it's very straightforward from what we have so far. All right. So yeah, the same concept, just like add between 0 and 4, just add up A and B. Between 2 and 7, just add up B and C. So it's not a problem. All right. I don't think I have enough time to go every single one of this. This one is gives us something else. I just do it quickly. Like I said, I don't have time for that. I have to move up to the main parts. And like I said, this class is like we have to read notes. We have to like do the Alex, and then if you have question, can ask. So um, I can't go over every single topic, but like I said, there's so many of them. So you're required to like read the notes and try to do the question on your own. So for this particular question that we need to so we need to figure out the area of a triangle, for example, right?
I do suggest, make sure that this is something that I use for not. Make sure that.
It's like 1/2 times base and the height.
And this will with just numbers, so like the numbers will work out. Let's say that you have an X in your grid of a factor, and you obviously need to do that first before you get to, because even in that scenario, you're looking at how to quadratic.
Base times the height.
Because this
Okay.
method of solving applies to quadratic.
So the questions gives us the height equal to 0.2.
But discovery.
Okay, so the height equal to 0.2.
Yeah, substitution is really not very common.
And
Like if there's a very specific scenario.
and then the questions ask us to find the area between 6 and 10.
And the other variable is the power of 2. and then like a variable to the power of zero, a zero to root term. And in those cases, you can do substitution, but you basically act as if
So the error between 6 and 10s, right? The probability that 6 and 10. So remember that this is not a triangle, so this is like a curve. So there's no we can evaluate this area. So I would simply take 100%, which is 1. This is the total area. Another curve, subtract the area between 2 and 3.
you find that 4 is the 4.
And then the area between 3 and 6. Okay, 3 and 6. So that's gonna be the thing that we're looking for. So 2 and 3 is like triangle. So this is like triangle. So this is basically the triangle. So you can have if you can have that being filled in the triangle section.
And the video also did.
That's good. I've never heard one of like a student like 10 level with the video. So you never.
Actually.
All right, so we're gonna fill with the triangle like right here. And then the area for that, like I said, it's like 1/2 times the base and the height. So this area just simply take the highest one. I'm sorry, the highest 0.2. So this one is simply we're gonna take like 1/2 of
Where you you
You have to memorize all 4.
1/2 times the base with like 1 or something, like the difference between 3 and 2 is 1 times the height is 0.2, so we can figure it out. This one just 0.1. Okay.
oh.
No, but those don't count.
And then we do the same thing when we subtract the area like between 3 and 6. So this area would be something like this. Between 3 and 6. So you're gonna have this, right?
Take a look at it.
So I'm gonna
The
feel
only thing is like I go on and because maybe like the solutions are kind of insane and then you basically just have to work out.
so we subtract this area. So this area is a little easier. So there's a rectangles, right? So obviously we can just compute it. The height was like the height is 0.2 times the length is like the difference between 3 and 6 is 3. So this one is 0.6, right? So this one is 0.6. All right, you're gonna subtract that. So the answer is like 1 minus 0.6 minus 0.1 is 0.7. So 1 minus 0.7 is 0.3. So the answer for that is 0.3.
Whenever like I answer this or something you can or cannot, or like whether you can or cannot.
Okay.
The answer is always going to be yes, comma, because.
It's five. The part B was 5 probability that a number pick is 5, so it's 0. Any probability at a specific point is 0, so it doesn't have the probability. And then find the probability pick between 3.3 and 5.7. So this like between the haptangle, right? Between the rectangles. So the probability for part C for part A was like 0.3, for part B was any specific point is 0. For part C that we have over here is we need to find a probability between 3.3 and 5.7. So this is like between this is between the rectangle. Okay. The rectangle that we have for those points. So we can simply just take the 3.3 minus 5.7 times the height, which is 0.2. So this is the length. times 0.2. And then you should be able to get this. You get 0.48 according to the calculator that we have. Okay, so that's the final answers. Yeah, every single question just like that. You're not required to do like calculus to integrate or stuff like that. Just simply know the fact that the total problem we have to add up to 100%. So any part that you can compute the area, we simply just like subtract this. Okay, so this is 0.1. The small triangle was like 0.1. This is 0.6. And this is 0.3. Okay. All right. Let's check the answers. I think that it is what we have. Okay. That's very straightforward from what we have over here. All right. Let me try out the different questions from Alex.
But all that changes is that instead of having the solution,
Yeah, this is the bell shape. Like I said, like the difference between. So the mean was 72.4. And then the standard deviation was 5.5. So we subtract 5.5, we're gonna get 72.4 minus 5.5. We got this one 66.9. And then we just add 72.4 plus 5.5. You got 77.9. So this is the difference of one standard deviation, and that accumulates 68% of the data set point. So yeah, and then that's what it is. Okay, 68%. Yeah, this one it's not a big deal. The question gives you different. 2 standard deviation is 95%, and 3 standard deviation will be 99.7%. In this case, should be 99.7%. We just simply take the average minus 3 step away from the means, subtract 3 times 90.4, and then take the average plus 3 times 90.4. So we should get this done. Okay.
Why is it down for you?
whenever you have a what this is telling us, if you have a sum of
All right, so this is like a normal curve, and then
Like 2 seconds.
so we need to know how to read the standard normal calculators. So let me just go to the next page.
Yeah, they were.
All right, we can use a calculator. So let's say to the left. So start from 2 to the left side, which is right here, and to the left. So which is the left side is over there. And the Z represent the standard normal distribution. Okay, so the standard normal distribution has the mean equal to 0, right? We start from the mean equal to 0.
all the special forms that you go for. And again, like I'm not saying this because I'm saying this because
Equal to 0.
equal 1.
And the standard deviation equal to 1. But this is just a chart that we get used to it. Like I said, it's not going to be on a test. And So it just helps you read the charts, and then either we also use the calculator to figure it out. So when you use a table, and for z equal to 2, that will be 0.9772. On the table, you can click on the table. Oh, we can also use a calculator, but I prefer you use a calculator, like I said, because it's going to be so much easier. So the z of um, all right, we can do this. Z of 2, so you can get the answer, which is 0.977. Hold on.
Is there like? The answer the question, 5 numbers, 5 numbers instead of 4.
And then that's going to give us the answer, which is 0.997, 0.9772, and which is like 0.9772. And it's not a problem to us. Remember, the total area under the curve have to be ones, right? The total area. Like I said, this is the normal distribution. So total area under the curve, the normal curve is 100%. So you might have some questions like asking us to, uh, you know, to find the area like z equal to 0, which is that one, and it's 50%, right? It's on the left side. Z is 0.5, so which is 0.5 over here. And then you're gonna shape the regions, and then you're gonna use a calculator to compute it. 0.5, you got like 0.69, something like that. It's not that bad. This question is pretty straightforward from what we have on the calculator. All right, I believe that's pretty much what we have for the regions. So let's move up to the standard normal. So I need to have like at least like, you know, 5 or 6 questions being solved. Like another 2 questions to solve until next Tuesday. All right, so let's continue on this. So I prefer people use the calculators on the exams, like the Alex calculator instead of using a chart. So for the first one, that we're going to take the so this one just so the size is greater than, so we have to take 1 minus because the total the calculator area only gives us the lesson area. So I'm gonna take 1 minus that. Okay, so let's do it on a calculator. So we can simply take 1 minus the p of less than negative 1.94. Oh, so sorry. And then it's just equal. We're gonna get this done. All right. All right, so that's gonna give us like on the calculator, it's gonna give us the 0.9738. Okay. The same thing for that. You're gonna go for B. And this one is straightforward. You just simply use a calculator to compute. Um, so just take the P of negative 1.43. You got like
Oh, okay,
this. And the answer for that is 0.07635.
well, 12, like, 30.
Sorry.
How would you go? Oh. That's fine.
This one, yeah, I'll go through that as well. So this is kind of the,
And then the question asks that you route to the 3 decimal place. You can do that.
Yeah.
And then the last one is like one to find an area between these two.
again, the base kind of process to solve it is exactly the same. The only thing that changes is that instead of having an answer in the form that is, or instead of having an answer that is gonna look like this.
So you're gonna take the bigger, subtract the smaller. You can find the area about in between by taking the big, subtract the small on the calculator, show you what it is. You can take this, oops,
Because, as you can see, you're gonna have
like
either
2
y multiplication.
minus
or,
0.9.
y
Okay, but you have to do like this.
minus 3 first, it's gonna be x squared. Outer, that's gonna be one of the two xy's. Inner, that's gonna be the other of the two xy's. And then last is gonna be the two y's, which is gonna be the other y squared. So the factoring and everything else works exactly the same way. The only thing that you have is an added y there. You could go so far as to act like the y doesn't matter.
Okay, so we just simply take the big, subtract a small on the calculator, so less, subtract a less, but a bigger value, subtract a smaller value, you're gonna get the area about it between those two, which also called a probability. So that's gonna give us the answer equal to 0.1613. Okay.
Yes, yeah, perfect.
And then of course you have to round up the 2 decimal place, 3 decimal place at 0.974, 0.076, 0.161. So that's pretty much what we have so far. Okay. All right. Any other question that you have? All right. So if there's no question, I feel like that's pretty much for today. So we went to like many different questions. I believe that we just completed one of the hardest part of the objective 4. So we know how to find the area under the curve. So we know how to read the chart. So once we come back next Tuesday, so I'll show you how to analyze and read the chart using the z-score. Okay. So, and how we're going to transform that. It's not too bad. But we still have like 9 topics left. I would say 1, 2, 3, 4, 5, 6, 7, 8 of them. So we would try to get it done by next Tuesday, and then I would let you focus on the topics that we have on the second exam. And don't forget that we basically have a data day before the exam as well. So the data day going to be in next Friday. No, I would say the data day is gonna be on 17. I'm so sorry. We still have week to do. Okay. Yeah. All right. Any other question? Any concern? All right. So if no question, let me take attendance. I will see you next Tuesday. Just please ask me question. You have any problem, like any challenges that you don't understand? Okay. All right. So let me take attendance real quick. We only have 26 people, 26 students. I think two got absent. Jasminer, Malika. All right. Annie, Rachel, Selena. No. Ashan, Samina. Gotcha. Uh, Sarah, Alexis. Okay. Sarah's not here. Yi. Okay. If you after you got your attendance taken, you can leave the class. Marlene is not here. Jocelyn, Larry. Um, I think I got two who was absent today. So yeah, the rest of you should be present. Okay, so all right, so have a wonderful day. Have a wonderful weekend. I will see you next Tuesday. Make sure we have office hour on Saturday from 1 to 3 p.m. If you have any question or concern, just get in the Zoom office hour. I will get notified. Okay. Yeah, Sarah is here. I'm so sorry. Um, yeah, I will get notified, just, and then I will join in and you have question regarding to objective or stuff like that, just let me know. Okay. All right. So have a wonderful weekend. Take care.